is over now. Just for a minute, sir. We'll conclude it now. Koshik sir and Jyoti sir, should I go to the next technical session?
Yeah.
Last keynote is waiting.
You can start the keynote. We have
Okay.
closed the session.
We have closed.
Thank you very much.
Yeah, good afternoon. Yes, good afternoon.
Sir, yeah, actually our technical session is over now.
So,
Please join.
is there any other link or the same link we have to continue?
The same link that is provided in the same Google Meet link.
Okay, right now we are.
Oh, you are here. Please start, sir. Sir, 1 minute just.
Senior grade at South Asian University, New Delhi, and a visiting professor at Maths and Computer Science, Liverpool Hope University, UK. He also holds a visiting professorship at NIT Goa, India. Dr. Bansal obtained his PhD in mathematics from IIT Roorkee, Information Technology and Management, Gwalior, and BITS Pilani. His primary areas of interest are social structure-based optimization, optimization SMO, which is being applied to various problems in the engineering domain. Published over 70 research papers in various international journals and conferences. He is the section editor-in-chief of the journal Methods X, published by Elsevier. He is the series editor of the four Springer book series AIS, ACTIC, ISTC, and SST published by Springer. He is also the associate editor of Engineering Applications of Artificial Intelligence, EAI, and Array published by Elsevier. He is the general secretary of the Soft Computing
For the cooperation, they develop certain kind of intelligent behavior, which is called the swarm intelligence. So swarm intelligence is nothing but an algorithmic approach or a systematic approach for the collaboration. And for that purpose, what happens, in the nature, we have seen a lot of social creatures which other. So usually the swarm intelligence based algorithms are inspired by those kind of social creatures, how they are collaborating with each other, what system they are following, what rules they are following, and if those kind of rules can be incorporated into the computer program, into a problem solving approach, and we can develop a intelligent algorithm, an intelligent algorithm which is inspired from the nature, which is not which mathematically derived algorithm. These all algorithms are not mathematically derived algorithm. They are actually the nature inspired algorithms. And particle swarm optimization, which is inspired by the birds flocking behavior or fish schooling behavior, ant colony which is inspired by the foraging behavior of ants, artificial bee colony algorithm, which is inspired by the foraging behavior of bird, beach. Few established example of swarm intelligence based algorithms. Then with the advent of the drones, people started to think that if one drone can do something, and instead of one drone, if we assign suppose 10 drones, 20 drones to accomplish some task, and if they have some cooperation of them, then the task can be done more efficiently as compared to the individual assignments. And therefore, the question arises how to collaborate, how to develop the collaborative protocol among the drones in a group. And therefore, the technology, the study of the development of the algorithm, development of the protocols, development of the system, so that a group of drones can collaborate with each other and can accomplish some task. So this is based on the birds flocking behavior. The drone swarm concept is produced, and let me tell you that drone swarm is an emerging technology and it has myriads of applications, faster and more efficient. You can see here I listed few. Of course, I'm going to discuss more in my coming slides. Surveillance purpose, for the collective cargo purpose, disaster, HADR scenario, human assistance and disaster relief, agriculture purpose for monitoring, for the uh, spray of pesticides on the crop. Uh, there are, of course, defense is the one most important area where the drone swarm is much required. I'll discuss this in detail. So swarm intelligence market is growing like anything. The concept of swarm intelligence is a hot topic in the artificial intelligence area. So swarm intelligence is important, drone swarm and drones are important. So of course, a new subject, the swarm and the drone, swarm intelligence and the drones will make the drone swarm, where the swarm intelligence based techniques are being implemented to the drones. And of course, the application very important application. Production applications are also equally important actually. Uh, Actually, what happens when a single aircraft, air combat is there, then if a single aircraft goes for the mission, the aircraft carries a pilot, the human is there, and the cost of the aircraft is also very high. instead of one aircraft, if I send 10 drones or 20 drones, the algorithms are being developed so that whatever the job one aircraft is doing, can these 10 drones or 20 drones can do. So the of course the technology is being developed. The same achieved can be achieved using the 10 or 20 drones as compared to our unmanned systems, and therefore we are in safe human life as well as the cost. The cost of the drones is much cheaper than the aircraft. This is the one, I request everybody to see this carefully. This is the one important video regarding the drone swarm. This is in this research paper was published in, I'm sorry, but can you hear me? My laptop got hang. Sorry. Mhm. Can you hear me?
Yes, sir, you are audible.
Actually, my system got hanged. I don't know what happened. So I'm just restarted my system and joining again. Just hold on, please. Just hold on. I'm joining. This is my mobile. I'm joining again with my system.
Okay, sir.
Uh, can you hear me? I'm sorry.
Yes, sir. Yes, sir.
It was, I don't know. This happened first time that my system got hanged. Uh, I think now you can hear me, right?
Yes, sir, you are visible also. You are audible and visible. Please continue.
To play this video, please have a look. This is the one research paper, supplementary material. This was paper in the field of the drone swarm, published in the 2018 in the Science Robotics Journal, which is one of the most respected journal in the world related to the robotics. So this is actually the introduction of the drone swarm concept. I request everybody to please see it carefully.
In this video, we will present fully autonomous multi-drone flights with a fleet of 30 quadcopters. They will fly in a confined area, avoid collisions with each other and with virtual obstacles. This is a challenging task that has never been accomplished before due to its
So drone swarm concept was never done before. This was the first time when they proposed this idea, and they have implemented the hardware also.
We started our project many years ago by studying natural phenomena that limit collective behavior. Animals, for instance, like birds or fish, control themselves by making decisions gathered from their neighbors, from local measurements, and other individual decisions. Drones are intelligent flying agents. When they are airborne, they make decisions based on the bio models that we have created. The uniqueness of our drone flock lies in the fact that they communicate with each other in the air constantly. Their flight is neither pre-programmed nor controlled by a central ground station.
Our goal today is to present a building block of collective motion. Our drones will fly in a tight formation and
So this was the first concept when it was published in 2018, where they introduced this, and out of that, we realized that the definition of the drone swarm, a formal definition of the drone swarm is here. This definition I gave in 2020, that and this is an interacting autonomous group of drones assigned to perform a or some task. First of all, this is the primary requirement of the drone swarm, that the group must be autonomous group. Autonomous means it must not be guided from the ground station. Its GCS must not be uh, guiding the drone swarm. Second requirement is that it should be, first is autonomous, second is it should be interacting. All the drones must be connected with each other. They should not be working in individual way. They are working as a whole. So they must be interacting with each other. The system should be autonomous. The decision by the drone farm should be taken on board, and it must be a group. 2 or 3 drones is not a drone swarm. It should be around 10 minimum. Actually, you can see my blog also. I have written a blog also that what should be the minimum swarm size. Then we can expect the swarm intelligence, and that is the drone swarm. So that is true for the drone swarm number. I found that minimum drones, only then we can expect the swarm intelligence. And there should not be only just for fun. They should be able to do some task. So assigned to perform one or more tasks. It is not necessary that they are assigned only for one task. One task, they may do more than one task also. Actually, this is another actually requirement drone swarm system, which I'll explain when I'll explain the classification of the drone swarm. So objective of the drone swarm is to develop a autonomous system consisting of a group of drones, typically 30 or more. I said that 10 drones doesn't mean that 10 is the optimal number. It is the minimum number. Optimal number 30 or more. So better swarm intelligence if you have 30 or more drones in the group. Then how they are connected with each other. So this connection is very important. I'll discuss this more, or let me discuss it here itself. Actually, this connection is called the topology of the swarm. How they are connected. Just imagine that these are the 5 drones. These are the 5 drones. Now they are connected like this. So this drone is connected to this, and this drone is connected to this drone is connected to this, and this is this. So overall, what will happen? That whatever the information this drone has, it will reach to this drone via these 3 drones, right? And this kind of topology is called the ring topology. But what other thing can be? Like suppose these are the 5 drones and they are connected directly with each other. So it is connected this, and it is connected like this, and it is connected like this. So now they are connected directly with each other. So everybody is talking to everybody. This kind of topology is called the fully connected structure. Of course, this is a very quick communication can be done, but action may take time. So this kind of topology is relatively actually slow. This is a slow topology. You may think that okay, everybody is connected with everybody, so it will be slow. Actually, overall it may be slow. It will be fast. Okay. So now the classification of drone swarms. So how we can get the robust drone swarm system? So there are 2 types of drone swarms. One is the fully autonomous swarm and one is the semi-autonomous swarm. Fully autonomous means like this, that there is after the takeoff and before the landing, everything is to be done autonomously on board computer. Based on the onboard computer, they are interacting with each other, they are sharing the information with each other and making decisions according to the algorithm that is already feeded, right? On the go, there is no intervention by the GCS. In the semi-autonomous system, man is on the loop. Here, semi-autonomous system, man is in loop. In loop means when if there is any means live feed or whatever the information they can provide to the ground station, the ground station is getting the information accordingly. The GCS or the pilot that is at the GCS is actually commanding based on that decision. The decision is being taken at the GCS, and then the drones in the sky are actually making it executed. So this is called the semi-autonomous system. And frankly speaking, semi-autonomous system is of course relatively safe. The accuracy may be relatively high, but it is still the man is in the loop, and therefore the scalability of this system is questionable. The speed of this system is questionable, while fully autonomous system is just plug, play and forget, just launch and forget kind of system. So here the scalability without actually having the human resources, you can launch 10 drone swarm systems. Not one drone swarm system has 10 drones, and 10 drone swarm system may have 100 drones total. So 10 different system, if they are fully autonomous, can be launched by a single person. But here in the semi-autonomous case, you require 10 pilots and 10 decision makers also. So ultimate requirement is the fully autonomous system. Another classification, there are two types of classification. Another classification is this: single layered and multi-layered. Actually, what happens in the single layered, everybody is equally capable. Everybody is equally capable in the single layered. In the multi-layered, what happens? There are some kind of mother drone kind of system. So it is suppose this is the one drone which is connected by these two, and this is connected by this is connected by this, and these two are connected by this, these two are connected by this, and these two are connected by this. So whatever is the information ultimately is reaching here, it is taking the decision, but they are in the pyramid form. They are in the pyramid form, and therefore this kind of system is not a very robust system. It is called the multi-layered. Just imagine if this particular drone is killed, then all these drones will not be connected with each other, because they are connected. These three are connected with each other. These three are connected with each other. They are connected. All are connected with the help of this only. So if this drone is killed or is crashed, then other drones will not be able to make a swarm. And therefore, single layered drone swarm system is actually required. Multi-layered drone swarm system is not a robust system. Okay. What are the most important challenges in the drone swarm? The very first that I already discussed is the topology of communication among drones. Actually, what happens if there is a local or ring topology kind of thing, like these three are connected, these three are connected. Suppose these three are connected, then if just imagine if this particular drone is gone, then only this will go. But if this drone is gone, then these three will lose the connection with these two. So the swarm will not remain as it is. So if you increase this, if you say that okay, all the drones are connected with each other, then in that case what happens, lot of processing of the information will be done at each node. All the drones are to process, suppose 10 remaining 9 information. Suppose 10 drones are there, then a single drone need to process remaining 9 informations. So it will take time, and the decision making may be delayed. But in case of the ring topology, what happens? They have to take the decision based on only the two inputs. Only two inputs they have to take the decision. So the processing time is reduced, and onboard computer capacity also not required too much. Too much capacity of the drone onboard computer is not required in this case. These are the only two simple cases. There are many other communication topologies also. For example, one is the von Neumann topology. Let me just tell you how it works. Suppose this is these are the nodes. These are nodes, means these are the nodes. Then they are connected like this. So there are many variants of communication topology. Every topology has one or other merits and demerits. And of course, we need to find out one optimal way to decide the topology, communication topology. And this is the one most important challenge based on the number of drones, based on the mission, based on the configuration of the drones, and based on the problem. So communication topology is not the unique one. It will keep on changing based on the available information or available resources. Another important challenge is all the points here are actually the research topics in the field of the drone swarm. Another point is the minimum number of drones required to implement the proposed strategy. Minimum number of drones required. If you have, suppose, a 1 by 1 kilometer area where you have to search something, and now this object is, suppose, 1 by 1 meter large or 1 by 1 centimeter large, then accordingly the number of drones will change. So for that particular purpose, what is the minimum number of drones required? It is to be decided. A lot of mathematical calculations are required, lot of based on the, of course. So this is another challenge. This is one, if we can generalize some, we can develop some generalized formula to decide the minimum number of drones for the thing. So the research, of course, is going on. Another challenge is the maximum and minimum distance between any two drones of the swarm. Actually, what happens, the drones are flying, suppose 6 meters per second speed. They are and they are keeping themselves apart signals based on the GPS coordinates. Now, if there is a GPS signal delay or there is an error, then they are moving very fast. And if they are moving very fast, they can collide with each other. In order to avoid this situation, the minimum distance is to be maintained. That okay, even if this delay is there, even if this error is there, they will not collide with each other. So minimum distance cannot be too close. And now the question comes that okay, if minimum distance should not be too close, then this minimum distance can be made, suppose 10 meter, 20 meter, large. But then what will happen? Suppose one drone is here and this is 10 meters and this is 10 meters and this is 10 meter. And if suppose this drone crashed, then the local network will not be able to catch this drone, and this drone will be disconnected with these two. And therefore, we cannot keep minimum distance too much. And therefore, there is another challenge that what should be the maximum distance. Maximum distance means if this is the one drone, these are the suppose 4 drones, then this is the maximum distance. Then this is the maximum distance. This distance is the maximum. So this should also not be, cannot be increased indefinitely or cannot be increased like anything. It should also be the minimum. Actually, the maximum distance should be minimum and minimum distance should be maximum to keep the swarm connected and safe. These are the two requirements, that a swarm should remain connected throughout the operations and should be safe throughout the operations. And for that, maximum distance should be minimum so that the connection should not be lost. And the minimum distance should be maximum so that they should not collide with each other. Another challenge is the self-healing. Self-healing means if suppose 100 drones are sent for one mission, and out of those 90 drones only reached to the destination, 10 drones on the way during the navigation fell down or crashed or enemy. So only 90 drones are now remaining. And suppose you need to destroy, for defense purpose, I tell you, suppose you need to destroy 1 by 1 kilometer area. Now, the minimum number of drones to destroy this area was earlier 100, but you have now only 90. Then the drone swarm algorithm should be designed in that way that these 90 drones can do as much as possible. They should not work as designed. Now they should know that now we are only 90. So we need to do more work than assigned earlier, right? So the algorithm should be designed in such a way. Okay. Another big challenge is how to communicate, how to navigate, how to accomplish the task if there is a GPS loss, GPS denied environment. If there is a GPS denied environment, in that case, how to take the decisions. Okay. There are these all these challenges I have already discussed. Now these are the application areas of the drone swarm. The very first area is the security, survey, monitoring, and surveillance. This is the one most famous, most important survey. I hope now everybody is aware that the government agencies, government of India agencies for the survey, whether it is state agencies or the uh, central government agencies for the survey purpose. Survey may be land area survey, survey may be the gas pipeline survey, electricity line survey, whatever kind of survey are there where the humans, it is difficult to send the humans, the drones can do it very, very easily, very, very efficiently, and with minimum possible cost also. So monitoring purpose, continuously 24/7 monitoring can be given by the help of the drones. Actually, nowadays, the new technology of the drones is coming that is called the tethered drone. So drones has one very big challenge about the battery. So if the battery is down, of course, it has to come down and recharge it, and then only you can relaunch for the monitoring purpose, surveillance purpose. So in that case, what can happen? The tethered drones, in the tethered drones, the power is supplied continuously from the ground. So one wire is there which is connected directly to the drones, and at particular certain height it goes and continuously monitor the entire. Suppose in my university I stay here, suppose there is a monitoring system that okay, if there is no unwanted element is there, so we can launch one drone which can be on 100 meters height and equipped with the camera and continuously powered from the ground. Then of course it can do the job of 100 guards in a particular campus. Okay. Disaster management system is one of the most important area. Actually, what happens, suppose there is a flood, then in case of the flood, people are missing. In case of avalanche, in case of fire, people are missing. First of all, the people are where the survivors are. The situation is there to reach, to plan for the other for the agencies at that particular survivor. So all this survey can be done with the UAVs or the drones. Drones can put some relief materials also near to the survivor, just for time being, by the time the help reaches to it. Of course, search and rescue is the one that I mentioned. Future is very, very bright. I told you that the swarm intelligence, global swarm intelligence market is growing like anything. This is the growth rate of the swarm intelligence market. And this is all because of the commercial and military end users. So particularly the defense area, if you are following the Ukraine war, then definitely you are aware of the drone power of the drones. This is the one research that we have done. So quickly, I share with you. The paper is freely available on archive, and of course, it's a published paper in the Swarm Intelligence Journal. In this paper, we have actually 6 objective problem and 12 decision variables. So first of all, we have reduce these 6 objects to 2 objectives using the PCA, principal component analysis, and then these 2 objectives are optimized using the NSGA2, and we found we compared the results with the 2018 research paper, and our research are quite impressive. So these are the 12 parameters. This is actually the class diagram of the drone swarm simulator that we have developed. I tell you, let me play this so that just a second. You see here, this is the simulation of our system which we have developed, and the problem is same that we have proposed in 2018 journal. So you can see here that it's a multi-objective optimization problem. So there are 2 solutions. One is the red solution and one is the blue solution. A red one has the flexible boundary and blue has the strict boundary. They have to be inside the boundary, and therefore you see the coordination in the red are better than the blue. So we saw that here in the blue coordination is less, but always remains the boundary. Here the coordination is better, but can go beyond the boundary also. Okay, this is another target tracking simulation where the drone swarm is tracking a particular target, and this target is dynamic target, and the same 2 solutions are there. This time the blue can cross the boundary and red will within the boundary. Now the target changed, they all changed their direction of movement. Okay, so this is a multi-objective optimization problem and unsupervised. So we have used the PCA, principal component analysis, which is this is the outcome of the PCA, and we found these 2 objectives which can be separated. So out of the 6 objectives, we made 2 objectives. These are the 6 objectives, and of course, these both are to be maximized. These both are to be minimized. So we multiplied them. Okay. So this is our result actually of the research paper, that you see that one solution was this solution and one solution was this solution. So this is our Pareto optimal front used using the NSGA2. There is another technology that we can use using our solution where the collision is allowed, and this kind of drones are there where the collisions are allowed. They are covered by some wired frame, so they do not have any any kind of misses, any kind of demerit in colliding, but they can maintain higher speed, they can maintain minimum distance possible, and can do the task relatively faster than the drones which are not allowed to collide with each other. Okay, so this is the overall outcome conclusion of our research that we have done. That's all from my side. Thank you so much. I'm okay to take the questions if there are any. Thank you so much for patience listening. I'm sorry I was not available at that time at 12:15. Thank you, Professor Day, for the cooperation. Thank you. So if there is any question, I'm okay to take.
Thank you, sir. Thank you very much.
Thank you very much, sir.
Yeah, please.
Thank you very much, sir, for your valuable session.
Yeah.
Does anyone have any question from the audience? Or anyone virtually connected with us? Does anyone have any question? Session.
I will ask. Hello, sir.
Hello.
Can you discuss about what are the potential problem in implementing large drone swarms?
Actually, the ideal drone swarms are actually the large drone swarms, and the potential problem that I discussed in one of my slide is how they are communicating with each other from the research perspective. Of course, from the hardware perspective, there is another issue, right? Size of the drone, carrying capacity, sensors. Of course, I'm not the expert in that area, but I know that what are the challenges there. In case of algorithm development for the large drone swarm, the major challenge is the communication topology. Another
Can
is
you
the
please
minimum
enlighten
distance between with
what
each
will
other.
happen
Another,
in a drone swarm? Suppose some of the drone lost their GPS signal, then what will happen? The entire swarm will be collapsed, or it depends on the topology.
actually, this is the one most important question. I'm really very happy that you understood. Uh, Actually, this is the region that the communication topology or robust communication topology is required. That if one or more drone collapses, or then the remaining drones should remain connected. And for that, the ring topology is there. In the ring topology, the neighborhood size is a one very important parameter. So usually it is three. To make it more robust, you can increase the neighborhood size. The fully connected structure is the one most robust. That if anybody fell down, there is no problem. But that system has to be very advanced system onboard computers should very high computing should have the, because a lot of information is coming, so they have to process a lot of information in minimum possible time. So these are the challenges for the algorithm development perspective, and for of course a hardware perspective. A lot of drones are there. Then their sensors, their size, their aerodynamical design, uh, their battery power, their carrying capacity. So a lot of challenges are there in case of the hardware. Yes.
Okay. Thank you, sir. Thank you.
Thank you. Any other question, or we can stop here?
Thank you very much, sir, for giving us time, your valuable time.
Thank you so much. Thank you so much. And I'm really very sorry. I missed initial morning time.
No issues, sir. No issues. Thank you.
Thank you.
We are honored that you are here, sir.
Thank you. My pleasure. My pleasure. It is my pleasure. Thank you. Please convey my regards to Professor Siddharth.
Yes, sir. Definitely.
Bye. Bye, everybody.
For sixth doctoral symposium on intelligence-based research, DOCR 2024, has come to an end. As we are in the verge of ending this intellectual journey, I thank our respected speakers, honorable participants, our guests, our audience for making this conference a memorable one. Your presence, your efforts, your patience has made this conference a successful one. Now I would like to call upon the stage our now we will move to our validated session. After 5 minutes.
that all prepared. That I have to deliver some few words extempo, right? Then presenting multi-objective optimization keynote. Anyway, this is the first initiative, I think, right, in college. So, heartfelt thanks and gratitude. And what is most admirable is that you took the initiative in spite of so many challenges, especially given the geographical location and other type of adverse situation. It's really admirable. And true that some point of time or other one has to stop. Because any process must have its point of initiation. So from that point of view, it is a milestone that Sukanta Mahavidyala could achieve. I mean, by organizing this event. It's an event serious in nature, so that is the good part. So, well, what happens is that it's a process of learning. This is the first time that such an event is being hosted by a college and that too